in due time. Okay, let's see. Let's get this one out of the way. All right, so this is B now. So looking at B, we've got, of course, again, I'm going to call this AY. And this will be BY. So sum of the forces into Y equals 0, AY plus BY minus, and I will let you combine these at this point. I think we can do that. You don't have to list them all. Okay, but you do have 30 kilonewtons going down, right? Sum the moment at A. You had 10 kilonewtons. That's trying to make it go clockwise. So 10 kilonewtons times 3 meters minus 20 kilonewtons times 7 meters plus BY times 9 BY, something like 18.9 kilonewtons up. 18.9 AY was what? 11.1 kilonewtons up. And if you look at my solutions, you'll note that I even put a box around those. It was just habit. On that first one, I put a box around. It's like, I really didn't need
those were your answers?
Yeah, I really don't need that number with a box around it. Duh. Sometimes, though, you know, old dogs, you know, what can I say? Figured I better say that before somebody else did. Okay, so now we're supposed to cut this one. It's still at, I guess, 4 and 7, isn't it? So at 4 meters, my free body diagram, and I kind of ought to just draw them right there beside it. So we go here, 10 kilonewtons. This one is 11.1, wasn't it? Distance here is 3 meters. God, that looks like crap. Sorry. And then the overall distance is still 4 meters where we're cutting it. So we'll do our shear. List all of it. It's 11.1 minus 10. It looks like we got 1.1 kilonewtons. It came out a positive value, which means the shear is actually, internal shear is going down in it, that location. The moment from the right side, if you will. We got 10, it's negative, it's going down, so we got 10 times 1 meter plus 11.1 times 4 meters. And that should be something like 34.4 kilonewton meters. And again, that direction. I have to make another move here. At 7 meters, more of the same, right?
This is when we got our bending moment where we have our force.
Oh, we actually, yeah, we're cutting it. We have to actually look at it to the right and to the left.
Yeah, and
Yeah.
that confused me a little bit on the problem.
And let's say bending moment, let's say 7 meters right. Okay, so we'll draw our free body diagram. 11.1, 10, and then we have 20. And this is 3 meters. This is 7 meters. So this time we're cutting it right at that location where that force is. So we have to look at it to the left and to the right. Okay, anytime you're cutting it right through that force, you have to go left and right. Is that going to be on the test, Ed? Very well could be. We'll see. I'm not going to make any promises.
So you don't take, like the force doesn't, you don't have to force, you have to put the full amount of force on both sides. Each direction.
Well, or do you? Yep. Let's just do it and see. Okay, so this is to the right. So the shear, what do we have there? Let's see, we've got this 11.1 minus 10 minus 20. See, because we're sitting over here looking at it, right? So we've got all three of those. You look at that, you got 1.1 kilonewtons of force. It came out a positive value, so the shear would be going, the internal shear would be going down, wouldn't it? If you're looking at it to the right. Do what? Oh, let's, I'm sorry, I put the, yeah, I'm looking at the wrong, I was looking at the wrong number. I was actually looking at the one just above it, this one. Sorry. Thank you. 18.9, isn't it?
19.9.
Huh?
Negative 18.9.
Yeah, 18.9. And it's negative, so I have to change that as well. So then I would say, or 18.9 kilonewtons up. The moment, 11.1 times 7 meters, right? Minus 10 times 4 meters. That's it. Oh, why don't we count 20?
20 times 0.
Exactly.
Is 0.
It's right at that point, isn't it? Can't be 20 times 0. You could put it in there, I guess, but be rather insignificant. I saw a thing on Facebook where it was one of those, you know, see if you can figure out what this number is based on, it was like 3 plus 3 times 0 minus 1 or some, or it was just the opposite of that, I guess. 3 minus 3 times 0 plus 1 or something, you know. But somebody actually said, well, anything times 0 is that number. Glad they weren't my student. You know, it's like, and half of them weren't getting. One person actually said the answer was 1. It's like, there's no way in this world you could have possibly gotten 1 for the answer. Or it's like, oh, I said, well, I suspect those same people have a hard time balancing their checkbook. It's like, wow.
So that shear force is the one that was wrong in these solutions.
Was this? No. This, no. Is, I don't know. What did they give for the?
Positive 1.11.
For, let's see now. No, that's the next one. That's on the left. That's looking at it from the left. I do believe. Let's see. We're still in 13.7, right? B.
Oh, you're right. Okay.
Okay. Now, let's see. Let's finish this one up. Gotta look in the right, I gotta look at the right spot. I got both of the solutions on the one page and it's screwing me up. 37.7
That's what I got.
kilonewton meters. Counterclockwise. Okay, so that's at 7 meters looking to the right. Now let's do 7 meters looking to the left. Again, I'm going to have to push these down a little bit. Oop, don't go too far. Okay, so now looking at it. There we go. To the left. Okay, what we got here? We got 11.1, 10. Everything's the same on this, right? 20. And we've got 3. And 7. Shear. Well, what if we're looking at that to the left? What do we're to the left side of this 20 now, right? We're just, I mean, we're talking just, you know, not even a thousandth of a millimeter, I guess in this case. We're just to the left of it. So if we're just to the left of it, we can't count the 20. So we've got 11.1 going up minus 10. That's it. 1.1 kilonewtons. It is a positive value, so the internal shear is going down, isn't it? Now the moment, well, let's see, we've got 11.1 going up, still 7 meters, minus 10 at 4 meters, still 37.7 kilonewton meters.
So when we look at it on the left and the right, the only thing that's different is
Shear.
looking back at the
Shear.
20 is included in the calculation.
Right. And the only thing that's affected there is the shear.
Right. But yeah, the bending moment's the same.
Yep.
So whenever you ask them to find it at a certain point, we have to move to the right and the left.
Only when there's a force there.
Okay.
Only when there's a force right at that position. Okay? Only when there's a, that's the only time you'll have to worry about that. Otherwise, we'd have had to do that earlier too, right? So, only when there's a force there. And why is that so? Remember back